Okay, so now we're going to go ahead and begin with the next section. So we're now going to be looking at 2.5. 2.5 and 2.6 are the last sections in this chapter, and I think they're two of the easiest ones. So these are going to first talk about functions and what is a function, and then also the domain and range. We'll do those with graphs and with ordered pairs, and then we'll look at equations after that. Okay, so how do we know if something's a function or not? Well, when we look at ordered pairs, and this is 2.5, ordered pairs are functions as long as all the x values are different. And that's the easiest definition that I can give you. We'll talk more about what a function is in the next section, but this one's just looking at ordered pairs. So ordered pairs are functions as long as all the x values are different. The domain is the values of x. The range is the values of y. So the domain is the values of x. Range is the values of y. And we're going to start with ordered pairs, then we'll move to graphs, and then we'll move to equations after that. So ordered pairs are functions as long as all the x values are different. Now the domain is the values of x. Range are going to be values of y. So we're going to begin with some ordered pairs. And there's several of these. These go with questions 5 through 9. But they're not difficult at all. So we'll do a couple of these to look at here. I'm going to give you some ordered pairs. And we're going to determine if this is a function. And then we're going to find our domain and our range. Now, is this a function? Well, let's begin by making a mapping. You don't have to make a mapping, but I think a mapping makes it easier to see. A mapping is just a visual way of looking at these ordered pairs. So this is going to be your x, this is going to be your y. When we look at our ordered pairs here, 3 maps to 5, 8 maps to 1, 4 maps to 5, and 6 maps to 3. Now, are any of the x values duplicated? No, every x value is different. As long as all the x values are different, it's a function. So it is a function. And why is it a function? All the x values are different. So all those x values are different, and that makes it then a function. Now what about the domain? Well, the domain again is the values of x. And we're going to list them like they would be listed on a number line. So the smallest values are listed first on the left, and then we put them in ascending order. So we're looking at our domain. And what's our smallest value? Well, our smallest value on the x would be a 3. Then we've got a 4. We've got a 6. And we have an 8. So my domain would be 3, 4, 6, and 8. Domain is values of x. Range is values of y. So what would the range be? Now for the range, we write duplicated values only one time. So looking at the y values, that's this column over here, what do we have? Smallest one is 3. 1, 3. So 1's the smallest, then 3. And then how many 5s do we have? We have 2 of them. We write them one time. So that would be for my range then, 1, 3, and 5. That one was a function. Now let's look at one that is not a function. So that one was. This one is not going to be. 5, 8, 3, 4, 2, and 7, 1. Okay, now this one is not going to be a function. I always like to make my mapping so we can visually see what's happening. X and Y here. 4 maps to 5. 8 maps to 3. 4 maps to 2. And 7 maps to 1. So would this be a function? Yes or no? No. Why is it not going to be a function? It's not a function because the 4's are duplicated on the x part, right? So the duplicated x values, that means then it is not a function. Why is it not a function? Duplicate 4's. So those duplicate 4's make it not a function. Next, we're going to look at the domain. Domain is values of x. So we list them in order. And it looks like the smallest value of x is a 4. Now, we do have duplicate 4's, but we list those duplicate 4's one time only. So we've got 4, 7, and 8 for my domain. What about the range? That's your y values. My range would then be 1, 2, 3, and 5. So that's my domain and my range for those ordered pairs. Now let's look at graphs. And when we look at graphs, we have what's called the vertical line test. And you might be familiar with this, you may not be. We're going to quickly talk about it. It's very, very simple. And this is going to be 4 graphs. We've got the vertical line test. In college algebra, you'll also learn about the horizontal line test. And that's for inverses. But in this class, we're only going to look at the vertical line test. So the vertical line test says this. You draw vertical lines. If any vertical line touches the graph at more than one place, it is not a function. So we're going to be just looking at graphs here, and we're going to be drawing vertical lines. And if any vertical line touches the graph at more than one place, then it is not a function. Very, very simple. Very, very easy to do. We'll look at several of these. We're going to find the domain, the range, and decide if this is a function or not. So that's what we're going to be looking for. So we need to decide if it's a function. We need to find our domain and our range. So is this graph a function? Yes or no? We draw vertical lines. Each vertical line, it only touches this graph at what? When you draw our vertical lines, they only touch that graph at one place. So this would be a function, because we only touch that graph at one place. What would the domain be? Well, the domain is values of x. And so here's our x-axis. We've got negative infinity to the left, positive infinity to the right. As I follow it up, what's it doing on this side? Okay, as I continue up, right, it keeps going up, and it goes up and to the what? Left, doesn't it? Right? What about the other side? What does it do? It goes up, and it goes out to where? The right, doesn't it? So my domain goes to the left here, so that's negative infinity, and to the right over here, so that's positive infinity. So my domain would be negative to positive infinity. Now what about the range? The range is the up and down part. And look at your graph. It's a U here, but does it ever exist down here? Does it go in the lower half of the graph? No. So where does it start at? On the y-axis, the up and down part, it starts at 0, and where does it go to? Positive infinity. So my range would be 0 to positive infinity. It's going up. Let's try another one. This graph. Is it a function? Yes or no? Do you think this is a function? Yes or no? Someone said no. Why would it not be a function? Because if I draw a vertical line here, look at what happens. That vertical line touches twice, so more than once. If it overlaps itself, that means it's not a function. What about the domain? The domain is the x values. And look here, okay, it starts clear down here. So clear down here on the left, following it up, and it goes to the right. So it goes to the left, and it goes to the right. So my domain would be negative to positive infinity. What about the range? Well, the range, what do we know about that? The range is the up and down part. It's going to start clear down here at the bottom, isn't it? Following it up, what does it do? Circles back around itself, and then it goes up and to the right. So it starts way down here at negative infinity, curls up, and then it goes to what? Positive infinity. So my domain would be negative to positive infinity. So it's not a function because of that loop back on itself. The domain is negative to positive infinity because it goes to the left, to the right. Range, it goes up and down. We'll do two more of these. What about a horizontal line like this? Is this one a function? Yes or no? Can someone tell me if this is a function or not? So I've got a horizontal line here. Now, how do we tell if it's a function? We draw vertical lines, right? Okay. Now, if I start drawing vertical lines, each vertical line, it touches the graph at what? Only one spot. So each vertical line touches the graph at only one spot. So a horizontal line would be a function. What about my domain? Does anyone want to take a guess as to what the domain would be? What's the domain again? X values. Negative to positive infinity because it goes back to the left, over to the right. What about the range? Well, the range is a little bit different. Can this graph go up or down? What is it doing? It's just a flat line, right? So is it going up or down in it? No. Where is it stuck at on the y-axis? It's stuck at what number? 5. So my range would simply be then what? 5. So the domain is negative to positive infinity because it's going left and right. The range is stuck at 5, and it is a function because it passes the vertical line test. What about a circle or an ellipse? Let's try a circle or an ellipse now. So I'll just make one up here. So here's going to be our ellipse here. Same as circles. It's going to work the same way. All right, so we should be able to answer this one pretty easily now. Is it a function? Yes or no? No, it is not a function. Why is it not a function? Yeah, it overlaps itself, doesn't it? Right? All over the place. So this one is not a function. What about the domain? Domain is the values of x. Now, it's confined to this ellipse here. It can't go outside of this ellipse. Domain is the values of x. So where does it go from on this ellipse? Well, on the x-axis, it goes from what? -3 to +6. So my domain would be -3 to 6. What about the range, the up and down part, the y values? Where is it stuck at on the y-axis? Can it go clear up here? Nope. Can it go clear down here? No. Where is it stuck between? On the y-axis, the up and down part. Looks like it's stuck between what? Yep, and write them as the same way they'd be on the number line. So the smaller value goes first. So my range would be -2 to 2. And you always write the smaller value on the left first. So that's your domain and your range. And it's not a function because it's an ellipse or a circle. Now we've talked about ordered pairs. We've talked about graphs. Now we're going to look at equations. And an equation is a function if it can be solved for y. So an equation is a function if it can be solved for y. And so that means these are not functions. Y squared, y to the fourth, y to the sixth, any of those. You continue that pattern onward. Also, inequalities. These are not functions because of the shading. The shading would make it break the function. So these are not functions. Most things are functions. Very rarely will you get something that's not a function. But anytime you have a y squared, or y to the fourth, or y to any power, it's not a function. In this class, we're only going to be finding the domain. We're not going to be finding the range. When you find the range, that's a little bit more difficult. And we get that range in college algebra. So in the college algebra, we find both the domain and the range. In this class, though, all we have to find is the domain. Now, there are two ways of doing it. It's either a function or it's not a function. So the first one is for functions. If it is a function, then your domain is negative to positive infinity. So that's the easy one. Unless it contains a fraction or a root. Okay, unless it contains a fraction or root. So x is in the denominator. That's what I mean by that. So let's look at functions first, and then we're going to come back and talk about things that are not functions. So we'll do the functions, and then we'll talk about things that are not. That way it's not too much at once. So how do I decide if something's a function? Well, I need to be able to solve it for y. If I can solve it for y, then it is a function. How do we find the domain for functions? Well, most functions have a domain that's negative to positive infinity. If it has a fraction, which means x is in the denominator, or it has a root, we have to do an extra step. And it's a little bit different. So we'll do 4 or 5 of these. So we'll do all the different types. And these are going to be functions at first, and then we'll look at things that are not functions. So I'm going to give you an equation, and you're going to tell me if this is a function or not a function. And then you're going to get the domain, and the range you'll get in college algebra. So we're not going to be finding the range, only the domain. Now, first off, is this a function? Yes, it is. Why is this one a function? Well, can I solve it for y? Yeah, I can solve this directly for y by doing what? By dividing by 3. So if I solve it for y, then I end up with y equals 4/3 x squared. We were able to solve this for y, so it is a function. Now, what about the domain? This is the easier part, I think, but students sometimes get confused. Do we have any fractions? No. Do we have any square roots? Now, you can have a square, but you cannot have a square root or any roots at all. Do we have a square root here? No. So no fractions, no square root. So my domain would then simply be negative to positive infinity. No roots, no x in the denominator, no fractions. Let's look at another one. About 3x minus 4y equals 2. So is this one a function or not a function? Okay, you don't have to really solve it completely for y. What you want to look for is to see if you can solve it for y. Can you solve it for y? Yeah. Now, what makes it not a function? If it had y squared or any inequality, it would not be a function. And we'll talk about those in a minute. But I wanted to do the functions first so we don't get confused with things that are not functions that are called relations. So this is clearly a function. And why is it a function? Because it can be solved for y. You can solve it for y if you want to, but we don't necessarily have to. What about the domain? Well, do we have any fractions? Is x going to be in the denominator? Nope. Do we have any square roots? Nope. So my domain would then be negative to positive infinity. And most of the time, that is what your domain will be. There are a few cases where it's not, but most of them are going to be negative to positive infinity. And we're now going to look at a couple of cases that are not, that have a different domain. So this one's going to have a different domain. Why is it a function? Well, has it already been solved for y, or can it be solved for y? Yeah, it's already been solved for y, right? It's y equals. So that tells you automatically that this is a function. So that's the easy part. What do we have in the denominator? This is our denominator here. Now, what we cannot have is division by 0. So we do not want any division by 0. So that means what we're going to do is we're going to set this denominator to 0 to find the point that doesn't work. And then we're going to solve. So we're going to set this denominator to 0 and solve. So x plus 7 equals 0. Move that 7 over. And now we've got x equals a negative 7. Now we cannot have negative 7. Because if I were to plug the negative 7 back in, I would get minus 7 plus 7, that makes it 0. And can you take 4 and divide it by 0? No, you cannot do that, because you cannot take a number and divide it by 0. That's undefined. It doesn't exist. So we find the number that's going to make it 0. And then how do we write our domain? Well, our domain is going to be everything else. So my domain would then be negative infinity to negative 7 with parentheses, union, negative 7 to positive 7. And what that is saying is every number can work except for what? Except for that negative 7. Because that negative 7 would give you division by 0, and we do not want that. We'll do 2 more of these fraction ones, and then we'll look at a couple of square root ones. So 1 more of these, and then we'll look at a little bit different one, and then we'll look at our square roots. Okay, so we're going to go through the same process that we did a moment ago. Is this one a function? Yep, because it's been solved for y. That's the easy part. What about the domain? Well, we have, again, a possibility of division by 0. So for that domain, we're going to set denominator to 0. And that would be then 2x minus 1 equals 0. Add your 1. Nothing new here. So 2x equals 1. Divide by 2. And so x equals a half. And that half is not going to work because 2 times a half is 1. And 1 minus 1 would give you what? 0 down below. And I cannot have that. So what would your domain then be? Well, my domain would be negative infinity to 1/2. U for union here. Then we use 1/2 to positive infinity. All that is saying is that every number is going to work in the domain except for what? Half. Because a half would give you division by 0. One more of these before we look at the roots. A lot of times I see students get this one wrong. Is this a function? Yes or no? Can someone tell me? It's easy enough to know. Is it a function or not a function? It would be a function. Okay, when we talk about the domain, and we talk about these fractions, what I mean by that is x is down below in the denominator. Now, when I look at this one, do I have x in the denominator, the bottom half of that fraction? No, x is not down below, x is on the top, on the numerator. So there's no x in the denominator. So there's no x in that denominator. So that means my domain, since there's no division by 0, would be negative to positive infinity. So if there's no x in the denominator, I can't solve anything equal to 0. So that means then that my domain would be negative to positive infinity. Now let's quickly talk about roots. So now we're going to move on. We're going to look at the roots here. Now, this one's a function again. Why is it a function? Has it been solved, or can it be solved for y? So this is a function. The domain is a little bit different. So we're now going to talk about this domain. When I talk about the domain, I've got roots. I have a square root. So since I have a square root, what you do is you set what's under the root greater than or equal to 0. And why we set it greater than or equal to 0 is because there's two things that we can't have when we work with values. We cannot have division by 0, because that's undefined, not possible. And in this course, we cannot work with negative square roots either. Because negative number under the square root, we can't do that. It's not a real number. In college algebra, you'll learn that they are complex numbers. But in this course, we just don't work with them. And since we're graphing, we want to set that root, what's underneath that root, greater than or equal to 0. So very easy. Let's go ahead and do this. What's underneath our root here? What's underneath our root is x minus 4. So we've got x minus 4 is greater than or equal to 0. So move that 4 over. X is greater than or equal to 4. Now you can either go directly to interval notation if you're comfortable with that, or just draw a graph quickly and find it. So x is greater than 4. So here's our 4. Square bracket, just going to open out in that direction. And my domain would then be 4 to infinity. Comes directly off the number line, just like we've done in the past here. So you set what's ever underneath that root greater than or equal to 0, and then you solve it. So very, very similar problem here. Is this a function? Yes or no? Would this be a function? Yes, it is. What about the domain? Well, we have a root, so we set what is under that root greater than or equal to 0. That way it stays positive, because if it's negative, we can't take the square root of a negative number. Not in this class. In college algebra, you learn that you can. It comes out to be an imaginary component of a complex number. But in this course, we really don't cover that. So we take what's underneath that root, which is 8x minus 3, and we say that is greater than or equal to 0. So then we simply add our 3 over. Divide by our 8. And x is greater than or equal to 3/8. And then on a number line, here's my 3/8. It's greater than or equal to, so it's going to be opening to the right towards positive infinity. So that would then be 3/8 to infinity with parentheses. Now the 3/8 has a square bracket. It's greater than or equal to. And that infinity is going to have a parentheses. So that's it. So it's a function. And all you have to do is set what's under that root, if you have a root, greater than or equal to 0. I want to look at one more before we take a short break, and then look at things that are not functions. So let's look at one more of these, then we'll take a short break. We'll come back and we'll look at things that are not functions, that are relations. xy equals 9. No? Sometimes students struggle with this fact. Is this a function? Yeah, because I can solve it, right? I can solve it for y. How would you solve this for y? Yep, divide it by x. And that leaves you with y equals what now? 9 over x. So this is the last function that we're going to look at. After our break, we'll look at relations. So this is a function because I was able to solve it for x. What about our denominator? What's down below? We have a fraction, right? And in the denominator of that fraction, we've got an x. So what do? We set our denominator to 0. And there's nothing to really solve here. It's already done for us, so what would our domain then be? Well, we found x cannot be 0, so my domain would be negative infinity to 0 union 0 to infinity. Right? So it is a function, and your domain is every number except 0. So we'll go ahead and take a short break, then we'll come back. Quickly finish up this section with just a couple of examples, and then do 2-6. So let's meet back here at 10:35. So let's meet back here at 10:35, and then we should be able to get through 2-6 today, and also some questions off that practice exam for that time. 2-6 is not difficult at all.